Good evening, my dear colleagues, students, friends, and subscribers. I warmly welcome you to this new video lecture in which I am going to explain Paul Romer's endogenous growth theory. Before I explain this theory, let me introduce Paul Romer, who is an American economist, and he is currently a university professor of economics at the New York University. He was awarded Nobel Prize in Economics in 2018 that was shared with William Nordhaus for his work in endogenous growth theory. Before joining the New York University, Romer was a professor at various universities, and that include the University of Chicago, the University of California at Berkeley, Stanford University's Graduate School of Business, and the University of Rochester. Before that, Romer was chief economist and senior vice president of the World Bank until he resigned in January 2018. Now let me switch over to Romer's growth theory. This theory was published in 1986 and it was thought of as a resurgence of interest in growth. Unlike the Solo's growth model, where the technological progress is treated as exogenous, the Romer's growth theory attempts to explain that the technological progress is endogenous. How it is endogenous? We'll discuss this in the coming slides. According to Romer, there are three important candidates for the sources of such progress, and these include: number one, new ideas, that is known as profit-seeking research, R&D, and innovative research; number two, international openness; and number three, human capital formation. The Romer endogenous growth model addresses technological spillovers or positive externalities that may be present in the process of industrialization. This model treats learning by doing as learning by investing, and the aggregate production function for the ith firm or the industry as a whole is given as yi is equal to a ki raised to the power alpha, li raised to the power 1 minus alpha, and k bar raised to the power beta. In this production function, k bar is the economy-wide capital stock which positively affects the output at the industry level, so that there be increasing return to scale at the economy level. And in the above equation, I stands for ith firm or ith industry. Now let us assume for simplicity that each industry will use the same level of capital and labor. Therefore, the aggregate production may be written as y is equal a k raised to the power alpha plus beta l raised to the power 1 minus alpha, and we remove the subscripts I. In this equation, a is assumed to be constant rather than rising over time. For example, we assume that there is no technological progress. It can be shown that the resulting growth for per capita income in the economy would be g minus n, which is equal to beta n divided by 1 minus alpha minus beta. Now what does this equation show? In this equation, g is the output growth rate, n is the population growth rate. Without spillover or positive externalities, as in Solo model where beta is equal to 0, the per capita growth would be 0 without technological progress. However, with the assumption of positive capital externality or positive spillover effects, beta is greater than 0, that is, it is positive. So we have then that g minus n is greater than 0, and that means that the average productivity of labor is growing. Now we have endogenous growth, not driven exogenously by increasing in productivity. If we also allow for the technical progress, so that the lambda in the Solo's growth model that we explained earlier is greater than 0, and growth would be increased to that extent. Since we discussed earlier that in the Paul-Romer model, one of the candidates for such process of growth was idea-based growth. So this model stresses the importance of profit-seeking research in the growth process. And then this was extended by Charles Jones in 1995 and 1999 papers into the following model. The aggregate production function takes the following familiar form, where y is equal to k raised to the power alpha a l sub y raised to the power 1 minus alpha. This is equation number 1. There are constant returns to scale to capital and labor, but the presence of ideas A leads to increasing return to scale overall. And capital is accumulated at the following rate. That is equation number 2, where k dot or change in capital is equal to proportion of income saved in invested. So this is investment minus change in capital due to depreciation. The third equation in this model is the workforce growth at a constant rate, that is delta L divided by delta L is equal to N, and that is constant. Then there is another factor to growth, and that is openness, international openness, and it may have two types of effects. Number 1, static effects, and number 2, dynamic effects. In static effects, there will be specialization by various countries and industries according to their comparative advantage, and within dynamic effects there will be increased market size, increased product market competition, access to foreign ideas and capital, and that includes knowledge spillovers, which has positive externality, and technology transfer. And also we may think of elimination of duplication in innovation. My dear colleagues, this is a brief introduction and explanation of Paul Romer's endogenous growth model. If you haven't yet subscribed to this channel, kindly subscribe to the channel, and also click on the bell icon so that you can be informed about my other videos that I'll upload soon for you. Thanks for watching this channel.